The following video clip describes how MassDEP's waste site cleanup program has derived soil standards for the PFAS compounds. It goes into a bit of detail about each of the different factors that are taken into account in the calculations. As you watch the video, however, remember that these soil standards are developed for a very specific regulatory context and include a specific risk management paradigm, which is just a fancy way to say, think twice about using these numbers for any other purpose other than the waste site cleanup program. They really might not be appropriate. But an understanding of how these standards were developed and their strengths and their weaknesses may be informative, if not directly applicable to the situation that you're looking at. Having put that caveat out there, I hope you find the following information informative and maybe it will entice you to learn more about the MassDEP's waste site cleanup program. Enjoy. Before we get into the details, though, I'd like to take a moment to talk about units. While it's always a good idea to pay close attention to the units you're dealing with PFAS compounds, this is particularly true. As you'll see, the levels of concern in the MCP that we'll be talking about will vary over several orders of magnitude. You know, of course, that 1 milligram is 1,000 micrograms and 1 million nanograms. You also know, of course, that concentrations in soil and water are measured differently. While we talk about parts per million in both media, 1 part per million in soil is 1 milligram per kilogram, while 1 part per million in water is 1 milligram per liter. To the extent I can, I'll try to avoid using parts per trillion or parts per million and speak specifically about nanograms per liter or micrograms per kilogram. I'll also use different colors for the units on slides to really emphasize the difference in units. Just a little reminder that there are a lot of soil standards. To start, there are 9 sets of Method 1 soil standards. That's because there are 3 soil categories, S1, S2, S3, and they represent a range of potential exposures, with S1 having the most exposure and generally being considered associated with unrestricted use or residential use, while the S2 and the S3 soil categories assume less and less exposure, including exposure frequency, duration of exposure, and the accessibility of soil. Regardless of the soil category, we're going to be concerned about the potential for contaminants in the soil to leach to the underlying groundwater. We know that there are 3 groundwater categories, GW1, GW2, and GW3. Unlike the soil categories, the groundwater categories do not represent a range of potential exposure. They actually represent different types of exposure. Groundwater 1 is for current or future drinking water sources. Groundwater 2 is groundwater that may be a source for potential vapor intrusion, and groundwater 3, which applies everywhere, is groundwater that will eventually discharge to surface water. So the combination of 3 soil categories and 3 groundwater categories and our concern for leaching means that there are 9 sets of Method 1 soil standards to make sure we account for each combination of soil and groundwater. First, we'll talk about the derivation of the MCP Method 1 soil standards in the general case. You've seen this type of diagram before when we were talking about the GW1 standards. The fact that we're using the same type of approach for the soil standards shouldn't come as a surprise. Starting over at the left, we look at the cancer and the non-cancer risk-based concentrations for the chemical of concern. Since we're now looking at soil, these calculations will take into account the amount of soil incidentally ingested by a child or an adult. It will also look at dermal contact, how much of the material that's in the soil can move through the skin barrier. Next, we look at a leaching-based concentration. So this would be a value in soil calculated to be protective of whatever the underlying groundwater standard will be. And then, as always, we have a sealing concentration to ensure that the calculations don't result in a concentration that would be so high that it would represent a gross contamination level. Having evaluated these 4 factors, the lowest or the most stringent of these 4 concentrations will be carried forward in the calculations of the soil standard. Just like we've seen previously, we also look at the background concentrations if they exist, and we look at the analytical detection limits to make sure that we can measure the values that we're concerned about. The highest of these 3 concentrations is then adopted as the Method 1 soil standard for that particular combination of soil category and groundwater category. We repeat this process another 8 times to get the complete set of Method 1 soil standards. Applying this approach to PFAS, we're only making one change to the general methodology, which recognizes that there are no published toxicity values to calculate the cancer risk-based concentration for PFAS compounds at this time. So with that box grayed out, we'll look at the non-cancer risk-based concentration, the leaching-based concentration, and the sealing concentration, and take the lowest of those 3 remaining values to move through the process. Everything else is still the same. First, we'll go through the Method 1 S1 GW1 combination. So this is Category S1 soil that lies above Category GW1 groundwater. You'll notice a lot of red and green. I've used the colors to highlight the difference in units that we're seeing here. The different colors helps me keep them straight and prevents me from making an embarrassing decimal point error. Moving down the boxes on the left-hand side, the first one is 0.25 milligrams per kilogram, and this is the non-cancer risk-based concentration calculated for PFAS compounds. Directly below that is the value of 200 nanograms per kilogram. This leaching-based concentration uses the established GW1 standard of 20 nanograms per liter as a target concentration and then is back calculated from that using very conservative methodology. I would note that there's still a lot of research being conducted on how PFAS compounds leach from soil to the underlying groundwater. This value of 200 nanograms per kilogram is certain to be revised as time goes on. Below that, the 1,000 milligrams per kilogram is the standard sealing concentration that we use for setting all S1 standards. The lowest of these 3 values is selected to move on through the standard setting process. This is where the units are important. 200 nanograms per kilogram is the lowest value. It's the same as 0.0002 milligrams per kilogram. We now compare this value to the background soil concentrations that might exist and the analytical detection limits. The soil background numbers selected for use in this process came from a study commissioned by the state of Vermont looking at sufficient soil concentrations of PFAS. MassDEP selected the 90th percentile value of the distribution of results for each of the 6 PFAS contaminants of concern. What you're seeing here, the 300 to 2,000 nanogram per kilogram range, is the range of those 6 90th percentile values. It's worth noting that the results of the Vermont study are also consistent with a smaller study done in Barnstable County. MassDEP believes that it's reasonable to assume that the concentration seen in Vermont would be similar to what would be expected in Massachusetts. And finally, 200 nanograms per kilogram was identified as an analytical detection limit for PFAS in soil. The final step in the process would be to choose the highest of these 3 values, and that would be the background concentrations of 300 to 2,000 nanograms per kilogram, depending upon which specific PFAS compound you're talking about. To set the Method 1 S1 GW3 soil standard, we'll follow the same process. And in fact, the only thing that changes is the target groundwater concentration, which for the S1 GW3 soil standard would be the GW3 groundwater standard. You'll remember that we set chemical-specific groundwater 3 standards for the 6 PFAS compounds, so the leaching-based concentration you see here is expressed as a range for those 6 PFAS compounds, 0.48 to 43 milligrams per kilogram. You might notice that these values are significantly higher than the 200 nanogram per kilogram value we just saw in the S1 GW1 calculation, and that's because the GW3 standards are significantly higher than the GW1 standard. Everything else remains the same: the non-cancer risk-based value, the sealing concentration, the soil background levels, and the quantitation limits. So when you put these numbers through the process, because of the change in the leaching-based concentration, you end up with a different S1 GW3 soil standard. Here, the 0.3 milligrams per kilogram S1 GW3 standard is based on the non-cancer risk-based concentration. Now, you're probably wondering, Well, what happened to the S1 GW2 soil standard? And the answer is it's going to look a lot like the S1 GW3. You'll remember that we did not end up calculating a PFAS standard for the GW2 category because PFAS is not a big threat for vapor intrusion. So imagine in that box on the left-hand side where the leaching base concentration would be, we would have 0 milligrams per kilogram. 0 because there's no target GW2 value. Everything else would remain the same, and if you follow through on the highest of these and lowest of those, you end up with the same 0.3 milligrams per kilogram value for the S1 GW2 standards. It just didn't seem worth putting in another slide to tell you that. So here are all the Method 1 S1 standards for the 6 individual PFAS compounds that we're concerned about. You'll see that where leaching to groundwater is a big concern, where the groundwater below the soil is being protected for its current or future use as groundwater, then the standards are significantly more stringent or lower than those areas where the groundwater is not protected for drinking water use. We see a similar pattern for the S2 Method 1 standards, S2GW1, S2GW2, S2GW3. If the soil is located above groundwater 1, groundwater being protected for current or future use as drinking water, then you see significantly more stringent standards than where the soil is above GW2 or GW3 groundwater. Will the same pattern hold for the S3 Method 1 soil standards? Yes, the pattern holds true. The standards for soil above groundwater protected for its current or future use as drinking water are consistently more stringent because of our concern for leaching to groundwater than the soil standards above GW2 and GW3 groundwater. In all these cases, the soil standards are protective for the direct contact exposures that we're worried about, but for any soil category above a GW1 groundwater, the standards are more stringent in order to be protective for the leaching to that groundwater. All these standards were set using the same basic methodology following that flowchart we've gone through several times.